In this part of the video, I'm going to just continue the discussion on the conversion of alcohols into alkyl halides with HX. But now we're going to focus on primary and methyl alcohols. So in this reaction, I will use ethanol as an example. And I'm drawing out my tetrahedral carbon on purpose. The first step of this reaction is very similar to the initial step in any reaction of an alcohol with HX. First thing that happens is the alcohol electrons attack the hydrogen electrophile. So here's a nucleophile attacking an electrophile, and the bond here breaks and the electrons are left on the halogen. My new bond. And now I have a positive charge on this protonated alcohol, and X minus is left. Now, similarly to secondary and tertiary alcohols, in order to get your product, your alkyl halide product, you have to break this carbon-oxygen bond. And that's what's going to happen. But we discussed in class, and hopefully you know, that this primary carbon cannot have a carbocation on it because the primary carbocation is just so unstable. And so instead of just this bond breaking, another thing happens at the same time so that we don't have to form a carbocation. And that is that the halide here attacks the carbon as this bond is breaking. So as this bond here is breaking, this halide comes in from 180 degrees away from the water, and it replaces the water bond by backside attack. So what's going to happen here is your halides coming in from the back, it's going to invert the chemistry or the stereochemistry around the carbon. Basically, it's going to do that umbrella flip where it pushes the hydrogens and the other carbon from going this way to going this way. And it pushes out the water molecule. So now, in only one step, I've gone from the protonated alcohol all the way to the product without forming a carbocation. And this part of the mechanism here is what's associated with Sn2 mechanisms. If I wanted to draw my reaction energy diagram for this reaction, I can do so. My reaction coordinate and my energy. I'm going to put my reactants here. So this is ROH and HX. The initial step in this reaction has to be protonation of the alcohol. And the protonated alcohol has slightly lower energy than the starting material. And then the products have a lower energy than the reactants because this reaction is exothermic overall. Oops. So this is where I have Rx now and water. But this concerted reaction is associated with a very high activation energy. So when I connect these, I'm going to make sure to show that this transition state is a very high energy relative to anything else. And that's because I know from experiment that this is my rate limiting step. Now in the rate limiting step, I have two things reacting. So that means that my rate is dependent on both of those things. So it's dependent on the protonated alcohol and the halide. Now, because there are two different types of molecules or ions in this particular reaction rate, this is called an Sn2 mechanism. So again, two things in the reaction law, or the rate law, excuse me, gives you the Sn2 mechanism. Sn2 mechanisms are associated with this concerted type of step where something is leaving the carbon, so this water here is leaving, it's called the leaving group, as something else is coming in and attacking from the opposite side. So this is called so a leaving group and the nucleophile, or the attacking group. Okay. All right, I think that's it for now. So please make sure that you practice using this information by solving problems on the lecture review worksheets or on problems from your textbook.